Welcome back to the class on electrical. In this lecture, we are going to discuss about the AC winding and winding factor for the AC winding. AC winding is nothing but it is an electrical circuit that we are going to keep in a armature of a AC machine. Some fundamentals are required before going to study the AC winding. That is, the first one is conductor. The length of the wire which takes the active part in the energy conversion process is called the conductor. Nothing but this is the conductor. This length is nothing but conductor. This length is nothing but a overhanging conductor. This part of the conductor only which is placed under the north pole or the south pole, that only giving the active part to convert the mechanical power into the electrical power in case of a synchronous chamber. Turn. One turn is consisting of two conductors. Nothing but this is the one turn. This is the one conductor. This is the another conductor. These two conductors are electrically connected by the overhanging conductor. There is no voltage will be induced in the overhanging conductor. Simply making electrical connection between these two conductors. Coil. Coil is nothing but the coil may consist in number of turns. This is the coil. Here it is consisting of two turns. The coil side has any number of turns, has a two coil sides. Suppose here this is the one coil. This is the one coil side. This is another coil side. This coil side may have so many number of conductors. Nothing but a multi-turning coil. Pole pitch. Pole pitch is defined as it is a peripheral length between the centers of two successive poles is nothing but a pole pitch. Electrically it is represented in the 180 degree. See here we have taken the two poles, one is the north pole and one is south pole. The electrically the centers of north pole and south pole, this is 180 degree. Coil span is nothing but it is a distance between the two coil sides of a coil is nothing but a coil. This distance is nothing but a coil span. How we are going to keep these coils in a armature winding means there are two types of this. One is full pitched coil, another one is short pitch. The coil span is equal to the pole pitch, nothing but a full pitched coil. So what physically it represents means one coil side exactly if you are keeping at the center of the north pole, another coil side will exactly have to keep at the center of the south. So in this case, the same amount of voltage will be induced in the two conductors. The resultant voltage across the coil becomes a 2 times one coil side voltage. Short pitched coil. The coil span length of the coil is not equal to the pole pitch, then it is nothing but a short pitch coil. This is the short pitch. See here, another coil seat is not placed exactly at the south pole. The voltage induced in this conductor and this conductor will be different. The resultant voltage here, what we are getting from the coil, that will be less than the two pitch. But here the advantage is that you can decrease the length of the overhang. That's why generally we are going for the short pitched coil, or another name is the fractional pitched coil or chorded coil. AC winding is classified into two types. One is the concentrated winding, another one is the distributed winding. AC winding. Now we are going to see the difference between the concentrated winding and distributed winding. Concentrated winding is nothing but suppose if you take one pair, 10 number of coils are there. The axis of all coils are the same, then it is nothing but a concentrated winding. Distributed winding is nothing but in a phase if you take the 10 number of coils are there, if the 10 number of coils are distributed in the periphery of a armature, then it is nothing but a distributed winding. The example for the concentrated winding is the field winding of a silent pole synchronous machine, field winding of a DC machine, primary and secondary windings of a transformer. Suppose if we come to the distributed winding, stator and rotor winding of induction machine, armature winding of both synchronous machine and DC machine. If the number of slots per pole per phase is integer, then the particular winding is nothing but a integral slot winding. If it is not an integer, then it is nothing but a fractional slot winding. Just one more classification is there, single layer and double layer winding. If one coil side is placed in the one slot, then it is nothing but a single layer winding. Generally, we are using this type of winding for less than the 5 kilowatt rating of it. This is the diagram for single layer winding. This is the one slot. In the one slot, we kept only one coil side. In a double layer winding, one slot is consisting of even number of coil sides. Nothing but 2, 4, 6 like that. It is very common to use the double layer winding for the power rating more than the 5 kilowatt. This is the cross-sectional view of a synchronous machine. This is stator winding. This is single layer. This is the double layer. If you see here, this is one slot. This is one layer. This is another layer. This is top layer. This is bottom layer. This is nothing but 2 coils per one slot. Now we are going to find out the pitch factor or chorded factor. Already we know that the coil is placed on the full pitched coil, then we are getting more amount of voltage. The coil is a short pitch, then the voltage induced in a coil becomes reduced. How much it is reducing? That will be taken care by the pitch factor or chorded factor. Here we have taken the two poles, one is a north pole and south. This is a full pitched coil. This is short pitched coil. Is how much angle it is short pitched means theta angle is short. The EMF induced in one coil side is E. Here also E. In case of full pitched coil, how much voltage induced in this coil will be equal to this one. So we are getting the 2E voltage here. But in case of short pitched coil, the voltage induced in coil side will be different from this one. Suppose if you take the E here, because of short pitch, the voltage induced in this coil side will be lesser. So the resultant voltage will be decreased. Now this is the phasor diagram of the short pitched coil. OE is nothing but the voltage induced on one coil side. This is one coil side. This coil side, the voltage induced on coil side becomes AB. Theta is nothing but a shorted angle. Suppose it is a full pitched coil, this vector will be coming on the x-axis. So these two vectors will be gets added. So whenever we are making a short pitch, there is some angle between the x-axis and the voltage induced in short pitch coil side. That is theta. Now if we find the phasor sum of these two, it gives the OB. This is the resultant phasor. Now here, for OB, we are drawing the one perpendicular bisector at a point D. Now here we are getting the two right angle triangle. This is one right angle triangle, this is another right angle triangle. This is the angle theta. The total angle is 180 degrees. So this angle is nothing but a 180 minus theta. So from the outer triangle, if this angle is 180 minus theta, then this angle becomes theta by 2, this angle becomes theta by 2. Because in a triangle, sum of all angles becomes a 180. Now, we are going to find out how much is the length of the OB. Nothing but a resultant vector. To find the total length of OB, we are finding the length of OD, that we are making a double. So we have to consider the triangle OAD. When you are going to consider the OAD triangle, then this length equal to, this OD equal to E cos theta by 2. Now OB equal to 2E cos theta by, that is equal to ER. Nothing but a phasor sum of coil size in EMF. Now arithmetic sum. So when you are going to find out arithmetic sum means if the coil is full pitched coil, then it becomes a arithmetic sum. Now the pitch factor is defined as a phasor sum of coil side EMF divided by the arithmetic sum of coil side EMF. So 2E cos theta by 2. Arithmetic sum nothing but a this E plus this E. So we are getting the 2E. 2E gets cancelled. Finally we are getting the cos theta by 2. The pitch factor is highly depending upon how much angle the coil is short. One more important name for the pitch factor is the chorded factor. We can use this formula for the fundamental component. Generally, the flux is consisting of harmonic. So, due to the harmonic, the pitch factor also will be different for each harmonic. For nth harmonic, the pitch factor for nth harmonic Kpn equal to cos n theta by 2, where n is nothing but a harmonic order. That is third order or fifth order or so on. Advantages. Because of the short pitched coil, the overhang conductor will be reducing. So, the overall length of the conductor will be increased. Moreover, it is going to affect the voltage induced in the coil. So, because of short pitched coil, the distribution of harmonics will be reducing so that whatever the voltage induced in stator winding is the tube triangle. Now, we are going to find the distributed factor. If we take the synchronous generator, in a stator, 3 phases are there. Suppose if we take the 10 coils in one phase, the 10 coils in one phase will be distributed throughout the stator periphery. See that we have shown here. Here I have taken the north pole, here I have taken 1, 2, 3 are the slots on the north pole. 10, 11, 12 are the slots onto the south pole. See, in one slot we are keeping one coil side, other coil side of the same coil we are keeping at the south. This is one more turn. This is one more turn of the coil. All these coils are connected in series, which forms a one phase winding. See, in this manner, the phase winding will be distributed on the periphery of a stator winding. The voltage induced in this coil side we have taken E1, this coil side we have taken E2, this coil side we have taken E3, this coil side we have taken E10, this is E11, E12. E1 and E10 is in phase voltages. E2 and E12 were the in phase voltages. E3 and E12 were the in phase voltages. It is the ratio of phasor sum of the EMF induced in distributed coil size in a number of slots under the one pole to the arithmetic sum of EMF induced in the same coil size. See, here is very important for one pole. Under the one pole, if we find the phasor sum of E1, E2, E3 for a one phase, the resultant voltage divided by the arithmetic sum of these voltages. Now, distribution factor is denoted by KD, that is equal to EMF induced in distributing divided by the arithmetic sum of coil size E. Now we are going to see the phasor diagram here. E1 and E10 are in phase voltages. So here we are taking E1, E2 and E11 are in phase voltage. The same manner E3 and E12 are the in phase voltage. Now here the difference between these two are the slot angle, one slot angle. So here the phase angle between these two phasors are the one slot angle. Now we want to find out the phasor sum of E1, E2. See here we know the phasor sum of E1. From the end of the E1, we are going to draw the E2. Nothing but we have to draw E2 in this manner. From the end of the E2, we have to draw E3. Again from this point, you have to draw E3 here with the same slope. So in that manner, if we complete the phasor of voltages under the one pole, it gives the polygon. AC, CD, DE, EF, so on. Those are nothing but a coil side voltages under the one pole. Now here we are defining the sum of the quantities. The number of slots per pole is Q. The number of slots per pole per phase is small q. The induced voltage in each coil is E. The angular displacement of the slot gamma equal to 180 by Q degrees. So here AC, CD, DE, EF are the coil side voltages. Each is displaced by delta degree. Now for each coil side voltage, we are drawing a one perpendicular bisector, that is a dotted line. All these dotted lines are intersecting at a point O. Now you take O as a center, this length as a radius. If we draw a circle, that circle will be passed through the A, C, D, E, F, so on. The lengths AC, CD, DE, EF are representing the chords of the circle. Point A, we are drawing one line. The same manner from the point C also we are drawing one line to the origin. Here we can find one triangle, that is OAC. Already we have drawn the perpendicular bisector. This angle is nothing but a gamma. Now this angle is nothing but a gamma by 2. Now in this triangle, small triangle, AOE, nothing but in this triangle, if we find the length AE, if we make a double of that one, we are getting the length AC. So now we are going to consider this small triangle to find the length of the AC. Now the EMF induced in coil side E equal to AC equal to 2 times the OA into sin gamma by 2. OA into sin gamma by 2 is nothing but this length, small length. That we are making a double. So we are getting the length AC. Now we have to find out the arithmetic sum. So arithmetic sum equal to Q into this value. Small q is nothing but a number of slots per pole per phase. So Q into 2 into OA plus sin gamma by 2. Now we are going to find out the vector sum because we want to find out the distribution factor. So the vector sum of AC, CD, DE, EF, so on, that is vector sum becomes AB. Now from length AB, we are drawing one perpendicular bisector to the origin, that is GO. Now we are going to consider the triangle OAG. From this triangle, we are going to find out the length AG. This total angle is nothing but a Q gamma. Angle becomes a Q gamma by 2. So from the triangle OAG, if you find the length AG, now AG equal to OA into sin AOB by 2. So this we are getting the OA into sin Q gamma by 2. We are multiplying with the 2 because we want the total length. That is equal to ER. Now distribution factor KD equal to EMF induced in distributed winding by arithmetic sum of the coil size of EMF. Already we know these two values. Substitute those two values, we are getting the sin Q gamma by 2 divided by Q sin gamma by. Suppose we want to find the distribution factor for the nth harmonic, then it is represented with the K suffix Dn equal to sin n Q gamma by 2 divided by Q into sin n gamma by 2. So now what is the difference between these two equations means this gamma angle will be multiplied with a harmonic number, so that the resultant equation will give the distribution factor for the harmonic flux. Distribution factor always less than the unity. Same manner pitch factor also always less than the unity. The winding factor Kw equal to pitch factor into distribution. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of the YouTube channel, so that I am always welcome to answer all your questions.